Hey Raghu, how you doing?
I'm good. Thanks for
Good.
having me.
Awesome. Yeah, so today we have Raghu Murthy from Data Coral. So for people who don't know who you are, do you want to give a quick intro?
Yeah, happy to. I'm Raghu Murthy. I'm the founder and CEO of Data Coral. My background has been in computer science, been working on distributed systems and databases for over 20 years now. Um, Started off working at Yahoo back in the day, working on their query engine that they were building in-house to replace Oracle, which was getting too expensive. Did that all over again at Facebook a few years later. Again, they were trying to replace Oracle with this time open source backed kind of system, which was Hadoop. And I was part of the initial team that built Apache Hive, and we open sourced it, worked on pretty much uh, every layer of the data infrastructure stack at Facebook over a period of like 5 years when they grew from, I guess, less than 100 million to over a billion users. But then if you think about the data, it went from about, I guess, 50 terabytes to like a couple hundred of petabytes. And we had to kind of scale systems and learned a lot, had a lot of fun. Um, and after that, I ended up leading engineering at a company called Bebop, which was started by the founders of VMware, which was eventually acquired by Google. And about 5.5 years ago now, I was an EIR at a VC firm called Social Capital out here in Palo Alto, and saw that a lot of companies in the social capital portfolio, as well as other companies that I talked to, had a lot of problems trying to build out their data stacks. They're all trying to hire data engineers to kind of piece together like an end-to-end data stack, and that is how I kind of chanced upon this idea of trying to make it really easy for companies to leverage data without having to spend a bunch on engineering. And that's what I've been doing for the past 5 years.
Interesting. That is quite the background. So, I mean, it's not every day. I think you get to meet people who, have worked, on some of Yahoo's key initiatives, let alone, Facebook's very early initiatives. So mad props for that. That's kind of cool. I mean, walk me through that history for a bit, because I don't think it's something that a lot of people get to hear about. So when you're working on these systems, I mean, it didn't seem like there was much of a blueprint for, you know, how to build systems like this. I mean, what was your process for thinking through these, solving these types of problems?
So clearly, at least at the very beginning, there was we were just problem solving, right? So there was a need to process large amounts of data. So this was like in the early 2000s, where um, the only other option was Oracle, and if you had like a few terabytes of data, Oracle became really expensive. So we had a bunch of machines that were lying around, and we were trying to figure out a way to parallelize data processing to do whatever joins or aggregates or whatever. We were actually writing programs for it. And these programs were running in on multiple machines. So that was the extent of uh, uh, kind of how we were thinking about solving those problems. Clearly, a lot of us had uh, CS backgrounds, and we knew how to build systems and in general. But at the end of the day, at any given point in time, we're just looking at the problem at hand and kind of solving them. And that is kind of how it played out even at Facebook, where there was nothing out there that we could kind of rely on. The interesting thing is I learned about how databases are built only after having built some amount of data processing systems. That is when I started learning about things like query optimizers and how do you use statistics for things for optimizing queries and stuff like that. And same thing at Facebook. The scale at which we were operating, there was nothing really out there that we could kind of rely on. Other than, of course, there's like decades of database research that at that point I'd also gone to grad school, and I was kind of reasonably familiar with the database research. Clearly, not uh, not too many companies were building databases at that point in time. Very few were, but for companies that could not or did not want to spend too much on these uh, kind of vendors, those are the ones that had the technical talent to then say, okay, let's see what we can actually build out there. And we're kind of inventing our way, maybe reinventing the wheel a few times because you build something and then you go back and read about it in like some academic paper, like, oh yeah, that's what I did. So it's like, yeah. So the end of the day, it's just engineering, software engineering that you're doing and working on distributed systems. So yeah, but of course, off late, there's quite a few companies that have kind of come out. All if you've been around enough, you see that it's kind of the same cast of characters that are moving between different companies, building newer and newer database, right? So that's kind of what it is.
That's really cool. Um, yeah, I mean, like I said, I'm always intrigued to hear about these war stories, so to speak, right? Because it's like you guys were inventing kind of in real time because you had to as well. It's not like this is some like academic paper that you were writing. It's like you had to build these systems to like keep the company alive. So
Yeah, I mean, it's so interesting. The what happened at Facebook is kind of comes to mind where we had one giant Hadoop cluster which had like a few petabytes of data, and we ended up in a situation where we couldn't build a data center big enough to hold the cluster for power reasons. So it's like now all of a sudden we had to figure out how we could split up a cluster with like petabytes of data to make it multi-data center, and we had between 6 months to a year to do that. So that is one of the things that I ended up working on, where like rethink every single layer of your stack, from storage to compute to query layer to kind of orchestration. Like this is the whole analytics stack, and start try to invent or like try to figure out how you can make it work in production for your customers, while also kind of changing some of the parts underneath so that it can actually work in a multi data center kind of architecture.
wow,
So that's then you realize that there have been a bunch of kind of parallel databases or distributed databases kind of work that has happened, and clearly there are some natural ways of solving problems. So you realize that those are also the ways that were talked about even in academic papers.
hmm, interesting. I mean, fast forward to today now, right? I mean, you're running a data startup
Yeah.
that greatly simplifies a lot of these workflows. Um, how do you make the transition, I suppose, from working at like almost an atomic level on these large distributed systems to now coming up with something that's very plug and play for the end user?
Yeah, so it's definitely been an interesting ride. The whole reason why I started Data Coral was because, uh, like I mentioned, I was in EIR, and this was around the same time, 2015 or early 2016, when serverless computing was becoming kind of popular. So things like AWS Lambda were getting some traction, and my take was something similar to whatever I've done in the past, which is there are all of these companies that want to do something very quickly. So they don't want to, like, we had like tens of engineers working on these systems that were kind of being put out there in these companies like Facebook. But for a small startup, they can't even spare like half of an engineer's time to kind of uh, set up a data infrastructure stack because it's just too expensive for them. So the particular kind of time when serverless computing was the one that was taking off allowed me to sort of come up with a way where you can actually spin up something very quickly. So one of the biggest challenges with these kind of large scale distributed systems is cluster management, right? So you have all of these machines that you have to keep up and running. Things might go up or down. So you're building a bunch of uh, scaffolding to make sure that your service runs reasonably well, even when there is hardware issues or whatever else. And for me, serverless was a way to completely stop thinking about that, right? Because the underlying kind of AWS, for example, would just take care of that. So then the question became, how sophisticated of a platform can you build on top of purely serverless? And turns out you can actually build quite a lot. And that is what we've been spending the past few years around, is leverage a serverless platform and then solve for specific problems that customers have. So, and clearly we built it in a microservices kind of architecture, which then means that it is plug and play. And each service that gets kind of added to this to this platform, it does one thing and one thing well. So we were able to also build it fairly quickly. So we were able to build quite a few data integrations very quickly, which are fairly scalable. And we are also able to connect to different warehouses. So we are able to provide a platform that allows uh, companies to be able to spin up a data infrastructure stack end to end in a couple of hours, all within their own environment. It's as if they hired a couple of engineers to kind of build a bunch of stuff, which then gets spun up in their cloud account, basically. So you're able to kind of simulate that by providing these Lego block kind of microservices that they can just add to their environment.
Yeah, that's awesome. And what are, I guess, some of the more popular data integrations that you're seeing right now?
Yeah, so we have built about over 80 connectors to kind of APIs, to file systems, to event streams, as well as to databases. And what we are finding, and not really a surprise, is that the largest data volume typically tends to be either in event streams or coming from production databases. So if you're integrating your production kind of Postgres or MySQL or Oracle or whatever into your data warehouse, that's where the most volume of data is. And also, we are seeing a rise in CDC, change data capture as a way to kind of do data integrations, right? So uh, typically, databases like Oracle or MySQL, Postgres, they offer a change log for all the changes that happen in the database. So instead of reading data directly from the database, you're reading the change log and then applying it in the warehouse. It has a bunch of nice properties. So we are seeing that getting more and more popular. And turns out our kind of serverless platform actually has been able to kind of handle like pretty large scales at like a low footprint. So that's something that we are seeing more and more of.
It's interesting. Yeah, I mean, it definitely seems like change data captures like been in vogue for, yeah, I guess, in the last few years now. I mean, it was something I think we heard a bit about, like here and there. But I mean, what do you think is like attributing to the, I guess, the rise of popularity with CDC? I mean, it's kind of gone mainstream. So
Yeah, I mean, it's clearly CDC as a concept has been around for a while, right? I mean, databases have used their kind of change logs as a way to do replication, right? But that replication has typically been mainly for uh, uh, creating replicas for things like disaster recovery or for high availability. But off late, this I would say maybe in the past five 5 years or maybe a little bit, actually maybe in the past 5 years, uh, especially these databases like Postgres, they've started allowing uh, other applications to be able to read that log, right? So that's why in Postgres it's called logical replication, as in it's not kind of just binary. Like you don't need another Postgres instance to read the changes. You can have some other client that can read the change. And what people I think are realizing is that because CDC was built on top of a solution, as in like the logging framework that is super robust, right? So it's literally meant to create replicas of a database. Using that same log to do data integration gives you a much more robust solution, right? So, and it has some really nice properties that it doesn't overload the database when you're reading the logs. So you can just kind of have like a very low footprint way of kind of getting the changes. You're able to get hard deletes. So if I'm doing hard deletes on the source, those show up in the destination as well. There are cases where like even schema changes can be automatically captured and then propagated. So you just find that CDC gives you a much more robust way of doing data integration. So in some sense, I think people are coming to the conclusion now that for them to get good quality or high fidelity data replication, CDC is a pretty solid way of doing it. And there have been players around for a while, but now I think there are newer uh, companies that are, or even open source tools that are providing these solutions.
hmm Yeah, it seems like it's definitely a growing space for sure. And I would say with growing space and growing popularity, I mean, are you seeing any maybe I don't know, anti-patterns with respect to CDC that people are doing? When
Uh,
I say people, I'm talking about the end user and pushing things into their data warehouses, for example.
I wouldn't uh, say that there are uh, too many anti-patterns. So, or maybe the one would be trying to do CDC into a data lake instead of a data warehouse that might support more efficient updates of rows. So, doing in-place updates in rows uh, 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 is one of the things that like even cloud warehouses like Snowflake and Redshift kind of do reasonably well. But if you're directly in a data lake, then you just get the stream that's just written out, and you're having to rewrite data over and over to get those changes. So those would be, I would just say that be prepared to spend more resources if you're on a data lake to get a CDC solution kind of going. Uh, but that said, uh, the advantages far outweigh the costs, I would say. It's more about with on the source side, as in clearly databases have supported CDC or like they have this change log, but most APIs and like most services don't really have that kind of a model. You're still fetching individual rows or getting updated rows. So that means that uh, uh, your the equivalent is to run a SQL query on a database, right? So it has the same kind of implications around not being able to deal with hard deletes, being maybe uh, heavy on their underlying database and so on. So I would say that CDC's only bottleneck, so to speak, is the fact that sources don't support uh, uh, like a CDC way of getting changes uh, rather than like for the user. If CDC would just work, then I would say most users should be okay with that. Unless I
Right.
don't know if you have seen it in your experience where CDC turns out it's definitely harder, as in
Yeah.
it's frankly deceptively hard to kind of set up. So that should get a lot easier. But uh, uh, other than the initial setup and stuff like that, it should be that uh, CDC is probably the right way to do data integration.
Yeah, I tend to agree. I think where I see it getting, I hate to use the word abused, but when people are trying to stream in, if there's a lot of changes in your source database, for example, and you're basically just carpet bombing your destination, like a Snowflake, for example, and it just can't ever catch up. That tends to be like one of the things I see, and that and like what was another one I saw recently? Like somebody was doing there's a continuous merge on a table in Snowflake, and so it could never actually catch up. It was just scanning the whole table all the time while it's trying to update, and it's like, and then it's trying to do the CDC on top, and that um, might need to
Yeah,
be looked at a bit.
yeah, absolutely. So I think what you've hit upon is the fact that warehouses are better suited for batch-oriented kind of updates. Uh, so that is one of the things that we have done is that even though we do CDC, we still do micro batches. We don't
Mm,
do stream. We don't try to do single row updates.
right.
That would be super expensive. So, but there are clearly cases where the volume of data may be small, but the number of changes might be too high. So then in those cases, again, if you have an end-to-end kind of pipeline kind of setup, you might get all the changes, but you only apply the latest change, right? You don't have to actually replay all of the logs in the destination if you don't,
Right.
right?
Right.
But there are clearly efficiencies that way that you can gain if you are okay doing a batch and are okay taking that additional latency because of the batching. So we have tried to find that balance. Like if people are okay at getting updates every 5 minutes or 15 minutes or whatever, then we are able to get enough uh, 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 kind of reduction in kind of the load on the data warehouse by just batching.
Right. Makes sense. Do you see any like and when we're talking about sources, do you see more sources kind of moving towards, I guess, more of an event-driven architecture, so to speak?
Yeah, there are a few, right? The one that I've actually mentioned to a few of our customers as well is Stripe. Uh,
Hmm.
where they have like a pretty solid API, and they have, even though you can actually fetch individual objects or like individual kind of entities from using their API, they also have an events API, right? And most other kind of services also have these webhooks that they offer where they can trigger a webhook whenever there is an event that is of reasonable importance. But then it comes down to coverage, right? So not many services out there offer kind of full coverage for all the objects. You still have, even Stripe, I think, I don't remember now, uh, most of the changes come in through events, but there may be these one or two objects that you have to explicitly go and fetch, right? So that is something that you'd have to kind of code or to account for. But yeah, as these services get more and more kind of event driven or have event driven architectures, making those events available for integrations is like a really a powerful thing that they can do. So interestingly, our platform itself is event driven. We have an event driven architecture. So we make our events available for our downstream kind of pipelines or whatever to be able to kind of react to data coming in instead of having it based on like if you're running a data pipeline downstream of our, let's say our CDC connectors, you can rely on the fact that data showed up rather than just doing it on a schedule, for example.
Mm.
So we ourselves are a source, like a CDC of the data pipeline. So you're able to capture all changes that happen to your data.
Is that in part due to the serverless that you mentioned you adopted earlier?
Yeah. So being serverless meant that we also had to build orchestration in a reasonably stateless manner, which then meant that we had kind of a central repository for all of our metadata, both runtime and configuration. And the orchestration, which was also serverless, was driven off of that. So that's kind of that that same metadata is what is available for our customers as well. And this is what actually I talk about in a couple of posts that I've done, which is this metadata first kind of architecture is mainly because of kind of these two things, right? So you start off with this pipeline metadata, as you call it, or the what are the different tables that are there, like how often are they getting updated, and all of that kind of information. And then you have an orchestration engine which is reading off of that, and then kind of essentially powering your data pipeline. But that just makes it for a much more scalable and robust way of like running pipeline.
I guess for the audience to back up, like when you say metadata, can you describe what you're talking about when you say metadata?
Yeah, so there are so there's like this metadata is all information about the data, right? So it's just metadata. That's kind of like a almost a non-useful definition. But here, specifically in the context of data pipeline, right, which is where we talk about being metadata first or metadata driven. This is information. So there are kind of two kinds of metadata. There is kind of configuration, which is kind of more static. And then there is your runtime metadata. So the static metadata is like, let's talk about an example of like an end-to-end pipeline where you're ingesting data from a source, you're running a few transformations, and then let's say you're publishing data back out into some other application. So there is a configuration of where the data is coming from, how often, what are the different tables that are coming from a particular source. So all of that is configuration metadata, right? And then there is, or when you're building transformations, let's say you're using SQL for your transformations, then you're building transformations on top of others, basically. That's how you're building data pipeline. So the data dependencies or the lineage, the schema level lineage at least, that is also part of the metadata, right? And then similarly, when you're connecting to a destination and when you're publishing data back out, the configuration about which tables correspond to which objects in the destination. So that lineage is also part of metadata, right? So that is your configuration of static metadata. And then as you're running the pipeline, your orchestration kicks off. It says, okay, I'm getting data every 5 minutes. So there is a batch of data that is being written to let's say a data warehouse. the fact that data was written to the data warehouse, or 5 minutes worth of data was written along with some statistics about the data, becomes the runtime metadata, right? So people then can leverage that runtime metadata to decide when transformations can run. So for example, if you're, let's say, joining two tables as a transformation, and those two tables are coming from two different sources, if the orchestration knows about when the data from each of these sources has arrived, then it can automatically figure out when to run the join query, right? So if you're running a daily report and you're waiting for data from, I don't know, Salesforce and your production database to show up, then your orchestration can handle the fact that data for that day has to show up from both Salesforce and your production database before the query runs. So that runtime metadata is what is used by the orchestration. So this is what it means by metadata first, as in you first come up with like what is the different kinds of metadata, like static and dynamic, and then you build systems on top of it, like you build your orchestration on top of it, and then you build whatever microservices that we have built out, like to be able to ingest data from different places or to run transformations in different warehouses. So they're all microservices, and they're all reading the configuration metadata, reading the runtime metadata, and doing the work that they do, and then producing their own metadata, and then writing it back to the same metadata layer or the metadata story, right? So I was talking to somebody about being metadata driven or metadata first, and they were talking about data catalogs, right? So there are a bunch of data catalogs around. So they're more reference data catalogs, as in you're reading from them. They receive data from the orchestration engine or whatever else and read from them. But the way we are doing it is more of an operational data catalog, as in your data catalog is in the critical path of your data pipeline.
Right. So you're not just tracking the assets; you're tracking I guess, the movement.
Yeah. So
And in a sense, you're defining the architecture too, aren't you?
come in?
Are you defining the architecture in this metadata first
Yeah.
approach as well?
Yeah, exactly. Right. So it's an event-driven architecture. So every time there is a new batch of data that comes in that generates an event, which will then trigger an orchestration kind of engine. The orchestration engine figures out what are the downstream dependencies of that batch of data, does the dependency management, as in like tries to figure out if all dependencies have been satisfied because this new event came in. And if all dependencies are satisfied, it can then trigger that action. And that action, once it is done, it generates its own event, and that's your event loop. Right?
Yeah. This is pretty cool. I like it. Huh. Do you know if there's an open source project doing this?
No, but we are thinking about open sourcing whatever we build.
This might be a good idea. So,
Uh,
um,
Trying to build something open source, we'd love to kind of work with you as well. If you're planning to start something before we.
no, but I mean, we'd be happy to pitch in. I think it's a cool idea. It just occurred to me that I actually don't think I've heard of this like specific take on, an architecture, and actually it was pretty cool. So, yeah. We'll talk offline about that. It's actually really intriguing. Yeah, I love hearing creative ideas like this, right? Because it's because you only get ideas like this that are born from, I think, really observing a problem uh, in enough great detail that you're able to like push forward. This sort of thinking. It's really cool. So, what kind of response did you get to your metadata first architecture article?
So clearly, at least whatever I've heard is like people telling me, "Oh yeah, so uh, so they already have a stack, right? So they most people have built out their own stack with like a whole bunch of tools to do different parts of their kind of data pipeline, and they're constantly struggling with having to switch between different tools to either author or debug or whatever else. But when they hear this kind of metadata first kind of approach, they're like, oh yeah, I think the fact that we are not doing the metadata first is the reason for all of my problems. Like I've had multiple people just write to me and say, I think you hit the problem on like squarely in terms of whatever I'm going through. because we are not metadata first, right? So that gives us, uh, I guess, gives me some satisfaction that, okay, we are actually solving the problem in a reasonable way. So our goal now is to see how we can get, uh, 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 I guess, make it so that maybe more people can contribute to this particular idea. So that's
Hmm.
something we're thinking about.
Yeah, I mean, I think it's something that's needed, right? I mean, because it's interesting, even within the world of plug and play
Mhm.
SaaS data tools right now. I mean, there's a bajillion of them. I can't even count how many there are right now, and but it's a cold start problem every single time you set up these infrastructures. It should be easy,
Right.
but at the same time, and I think it's easier than maybe when like you were inventing Hive back in the
Mhm.
day, um, but it's a different sort of complexity now. Now it's a matter of okay, I have um, at least the things that I'm seeing, you have endless amounts of tools that'll sort of accomplish similar-ish things. And I need basically at the end of the day, I need to move data into, we'll just take this example, move data into a data warehouse and make reports. Pretty standard stuff.
Mhm.
Um, but every single time, it seems like it's a cold start problem.
Yeah.
Like everyone starts from scratch every single time, even though this should be easy.
Yeah, that was
So.
one of my things. Like it was 2015, and like by now, people should have figured out how to just make it a push button. It doesn't have to have so many kind of different variants, right? So
Mhm.
I kind of look at this as like there've been a huge number of tools that have come up that all do one thing and one thing well, but then they have their own underlying implementation with its own metadata basically. And the fact that the metadata is not consistent means that uh, you have like a impedance mismatch between tools, or basically a split brain problem, right?
Mhm.
So where you're trying to uh, switch between different tools and you realize that they call things differently in each of these different tools, and then you have to know the translation by like manually trying to figure out how you're going from one thing to another, right? And this is the constant kind of cognitive load that everybody has, that we are uh, that people just assume this is how it's done, right? So there is no other option. Right.
It's like daisy chaining all these black boxes together. But they're also black boxes that with each, we partner with quite a few companies, with my company, and it's like, Fivetran, they have their own certification now. It's kind of crazy, right? And then you got like yeah, no worries.
Sorry about that.
No worries,
It's
man.
like my phone went off and like my kid was running in the
Oh,
background.
it
So
happens, man. I can just cut this part. Yeah, it's all good.
sorry about
Yeah, I got kids too, so and it's April Fool's Day. They're having a lot of fun right now.
that. No, yeah,
So yeah, they think they're being funny. So and then all my stuff ends up missing. Um, but yeah. I mean, I think you hit on an interesting point, though, right? I mean, for as I guess simplified as the managed service or third party vendor world is right now, there's still a lot of complexity. I think precisely because of, I think what you've observed, where it's sort of every company is going off doing its own thing, trying to solve a similar problem, but in their own unique way, and then hence you have this. Um, I can't remember what you called it. Uh, I don't know. I just called it black boxes or whatever. But you're just trying to bolt all these things on together that may or may not reconcile.
yeah, yeah.
So it's and the complex too. Like I said, one of our partners, Fivetran, like they have their own certification now, and it's like I think it's cool. It helps designate partners, and
Mhm.
if you know the tool well enough. But at the same time, it is sort of ironic, and in that these tools are meant to simplify everything. So, but
Yeah.
it is what it
I mean
is.
that's yeah. I mean the it's I think a sign of the times, right? That
Mm-hmm.
we are uh, like things were really hard. You had to hire engineers to be able to kind of build all of this stuff. Now you do have tools like Fivetran that have made them kind of really easy. So that is awesome. But then it turns out there are a bunch of other tools as well that may be doing some things that are slightly different than Fivetran that you also want to bring in. But now you end up in the situation where you have to make both of them work together, and that becomes uh, the complexity. So in my mind, like data engineering kind of went from um, building software to kind of do these operations to an tool integration problem where you're trying to piece together a bunch of tools and then trying to write glue code so that they know how to talk to each other, or bring in like other tools like Airflow to kind of help orchestrate things, or like an Alation or Collibra to make sure that they all kind of send information to some other tool that you can then get the single pane of glass.
Mm-hmm.
Right? So your data engineering has essentially become that kind of complexity now. And
Yeah.
I don't see that complexity, uh, let alone decreasing. I think it's going to only increase because of the number of tools.
This is such a good point. And in fact, I was struggling with this today because I'm actually writing just got the okay to write an O'Reilly book on the fundamentals of data engineering. And so, I might actually have to pick your brain on some of this stuff. But it's actually thinking about this exact thing today, right? Where, yeah, the role of a data engineer has become, I mean, I think the ability to write software and write good code is still required. But I think to your point now, it's a matter of just filtering, okay, so like what tool am I going to use for the job all the time while maintaining sort of because part of the job of data engineering too is to make sure your data model is consistent with business definitions and, you just can't randomly change out tools and your data changes because that doesn't really help anybody. So how do making that balance, right? And there's only going to be more and more tools. And yeah, I had the same insight today where uh, it might have actually been easier to be a data engineer back in the day in the sense where at least you had a handful of tools to work on. Yeah, sure, they were difficult, but you didn't have not just tools, but new paradigms coming up, right? Like now you bring up metadata first architecture. Like this is cool. So
Yeah, I mean, I would say that this is happening not just in data, right, but pretty much everywhere where
right.
um, uh, early on there was a few people who were the only ones who even had the opportunity or even were allowed to work on those things because it was just too hard.
Mm-hmm.
Then things became easier, and then you start realizing that it's easy now enough for people to start doing stuff. I mean, before there were the clouds, not many data integration companies were around, right? Only when the cloud came along is when it kind of decreased the barrier for companies to enter into the data integration market, right? So then what ends up happening is uh, now there are more and more companies that are able to leverage data because of these tools, because the barrier has been reduced. But then the complex, something's got to give, right? So the thing that uh, you're having to pay for is the increased complexity of the number of different tools that are around, and they all have slightly overlapping functionality. So your job as a data engineer in a company is to almost like a Picasso painting, right? So you're trying to create this kind of patchwork of tools and hoping, even if there is overlap, you're trying to say use this tool and not the other, and then chances are there's a bunch of gaps, and now your job becomes, should I find another tool to fill the gap, should I write code, and like you're constant, I think the cognitive load or like the amount of things that a data engineer has to think about now has actually increased because there are so many things there are so many moving parts basically, right? Early on, we were the only ones writing code. We knew exactly what was happening. So the entropy was lower, I guess. Um, so yeah, so our take is more that by having this framework, this three-layered framework that came up with, which is there's a data layer, and of course there's the DevOps tooling layer that people use to kind of interface with the tools. But then this middle is this hidden middle that every tool has to build out. If you were to take that out and make that standardized a little bit, then it'll allow for more of an open system where more tools can plug into the same metadata layer. And the authoring experience or like the DevOps tooling experience can be standardized a little bit, or at least made easier, right? Because it's going against the same kind of same middle metadata layer.
Mm-hmm. Interesting. Huh. Um, yeah, there's a lot to think about there. So, uh, I think in another article I saw recently, you're talking about, I think it was an Ask Me Anything. So one of the things that you answered was, like, I don't know, you kind of, I think it's a question about data architect and the role of a data architect these days. What is the role of a data architect these days? And I suppose to back up even further, like, what is a data architect these days?
Yeah, I think we touched upon it just in the past few minutes, right?
Yeah.
So, uh, like back in the day, the role of a data architect was to uh, almost from first principles solve the data problems of a particular company, right? They had a few tools that they could use, one of them being Oracle for sure. right? And it's kind of ecosystem of tools, and they would kind of figure out how to kind of piece things together. But then, off late, given the sheer number of tools that are out there, or even kind of paradigms of kind of how to like, uh, you're talking about metadata first, but prior to that, there's like this whole Lambda architecture, Kappa architecture, and like there's all kinds of architectures that are being kind of talked about. So as a data architect, I think the best that you can do is figure out what combination of tools would suit your needs now for the next couple of years, let's say. And then you haven't really painted yourself into a corner that you have to rip the entire thing out and replace it if like the scale increases or the complexity increases. So you, at the end of the day, you're trying to make these decisions that allow you to kind of just replace small parts of it instead of uh, just kind of getting kind of sucked into just one architecture, right? So I think uh, this used to happen like if you had to go from, let's say, like Oracle to Microsoft SQL Server, it's basically entire rip the guts out of it and replace the entire thing. But nowadays, you can take a Fivetran or replace Fivetran with some other ingest tool while still you might have dbt, and that's still kind of okay. But you need to know for your requirements, is Fivetran the right solution or something else? Is dbt the right solution, or is there something else? For orchestration, which tools do you use? So again, uh, in some sense, you're solving like an optimization problem uh, that where you have to kind of pick from tens of options for each of the things that you want to do, right? So you're solving that combinatorial explosion problem, and that has essentially become the role of a data architect, I would say. And once you pick the choices, then clearly it's about implementing it and making sure that it succeeds. So that's the implementation side of things, but there's a ton of work that happens with the team.
Mm-hmm. Yeah, and I guess in a rapidly evolving field, like the data tooling space, pick any niche you want.
Mm-hmm.
I mean, if you're a data architect, how do you determine like what's the winning tool that I need to pick for this particular use case?
Uh, the honest answer is you don't really know. So that's why a framework like this, kind of the three-layer framework, kind of helps, right? So uh, you're you're not thinking about each of these tools to be completely kind of isolated with their own kind of. Uh, you're picking a tool for its capabilities, but how much familiarity do you have with what you have gotten yourself into? As in, what are the implications of picking this tool for your kind of the DevOps tooling layer? What is your debug flow going to look like by bringing a new tool on board? So do you have like a mental model, or do you have an opinionated way of how you'd want your data teams to be operating on a day-to-day basis? So that would, in some sense, like, and our hope is that by this kind of three-layered framework, as a data architect, you can think about, okay, for the data layer, I want to move data from point A to point B. Here is a tool, but let me also try and understand what is its metadata, and also let me understand what is its kind of DevOps tooling layer. How do I author stuff? How do I test stuff? How do I debug stuff? And how do I deploy things? How do I monitor things? So uh, having this kind of a framework at least has allowed us to kind of talk to companies as they are thinking about building their data stack to say, it's fine for you to pick this tool for this functionality in the data layer, but here are the implications in the metadata layer and in the DevOps tool.
That's really cool. I guess kind of closing out, like where do you see the future of data tools moving maybe in the next 5, 10 years?
Uh, there'll be more tools in 5 years than there are now. So that's kind of like a
Scary.
and, I mean, when I started out in like 2015, I was like, there are too many tools, and now there's probably like 10 times more tools now than there were 5 years ago, right? And I do, but that said, I do think that there'll be more consolidation of kind of architectures, if you will, or at least, I mean, that's what we are hoping will happen,
Right.
is that people start thinking about uh, uh, kind of a coherent way of building it would be to start with this kind of middle layer, and then then it becomes plug and play, right? So it doesn't matter what the underlying data layer does in terms of if you find like a faster or a more robust kind of data integration tool or a tool that allows you to kind of store and query data a lot faster, you can just plug and play, or you can just replace some parts of it. But your kind of the destiny of your data stack is in some sense kind of determined by how robust or how clean your metadata layer is, right? So that's kind of how we hope to kind of push uh, the conversation as well.
Hmm. Yeah, I hope you're right. Because, I mean, just given the stat, I mean, what you said about the explosion of data tools, I completely agree. It's inevitable. And plus, if you just zoom out, I mean, the VC market too, it's just, it's flooding the data tooling space with money. So it's just very attractive. Everyone's going to be making a data tool right now, right? And so, what also is interesting, I think your take on this too, is like, I mean, there's more data tools in each niche popping up. I mean, do you think you're going to start seeing overlap within niches and maybe niches blending together at some point, or?
I mean, that's already happening, right?
Mm-hmm.
So even if you take uh, uh, the tools right now, there are overlapping capabilities. So uh, you have to kind of pick and choose the capabilities of each tool that you want to use as a data architect. And I'm sure there'll be kind of newer things, especially around compliance or like
Mm-hmm.
anonymization stuff. There's very few players in that kind of space, but I'm sure there'll be more that will come along. But turns out there'll be overlap with data ingestion as well as transformation. So everybody will be trying to kind of jostle for like the problem of the day that they want to solve. And there is definitely going to be overlap. There's no question about it.
Yeah. I mean, what do you see that overlap extending into? I guess ML ops, ML engineering are the two buzzwords of du jour.
Yeah, yeah,
You,
absolutely. Yeah, go ahead.
Now, what would that look like? I suppose the
No, no,
overlap
I
of
mean,
DE to, yeah.
in our mind, like ML or like building machine learned models or uh, uh, like even serving models, they're all like in our minds, they're just data transformations.
Mm.
So the same orchestration kind of challenges exist. The same requirement to know about kind of data lineage exists. Um, but they're all solved kind of almost separately right now. The only common kind of element being the orchestration layer. Again, I think that thinking about the metadata for ML pipelines is something that I think people are coming towards, and it does make sense as you can imagine to kind of merge the two, right? So
Mm-hmm.
the metadata can be the same. The kind of transformations that you're doing could be different, right? So it might be a SQL transformation. It could be a transformation where you're learning a model.
Interesting. Do you see the same sort of merging? Do you think it's going to happen with software engineering and data engineering?
Huh. That's interesting. Um, I so there. I mean, I think there you're talking more about the DevOps tooling layer, right? So will there be more and more will building data pipelines look more and more like writing code? Um, or
To some extent, like right now, to me, it seems like there's sort of this weird artificial boundary between like software engineering and building apps, and analytics or machine learning on the other end. Um, and with the different paradigms, maybe CQRS, for example, or just other types of paradigms that come in, it seems like maybe they'll see its day in the sun at some point. But
yeah,
yeah,
I think it'll blend, right? So if you're a software engineer, like a few years ago, you had to know how to use a database.
mm-hmm,
You still do.
right,
So similarly, you have to build applications. You may have to learn about how to build a model, or at least how to use uh, some APIs that will get you to kind of do some inference or whatever else, right? So,
yeah,
and I think there are companies that are doing that too, making it so that software engineers can leverage data in interesting ways.
mm-hmm, yeah.
But
It's
I
just
don't know if it'll start making them to become software engineers versus data engineers.
right.
I, that's interesting. I it'll just be about building applications, and there are different things that you need to do to build applications, and many of them are about doing data.
Mm-hmm.
There'll be tooling that will make it easier so that it will all be available through APIs or whatever. But maybe that is how it will blend into.
Yeah, because I've been thinking about this a lot, just like the data lifecycle. And the more I start thinking about the data lifecycle, it just seems like there's this weird, almost artificial distinction right now between like software engineer, data engineering, and then even ML engineering. Like at the end of the day, like, we put up these barriers just because I think well, they're necessary right now. But as I think there's more abstraction layers, distinctions might become blurry. I have no idea. Could be totally wrong too. But um,
I mean, people are building data-driven applications.
mhm,
So in that sense, engineers are having to understand how to fetch and process large amounts of data.
mhm,
And there are tools that are making it easier as well.
right.
So yeah,
Yeah.
uh,
Who knows? Well, awesome. I think it's a good place to wrap it up. Is there for people who want to learn more about you and your work at Data Coral, what are some ways they can find out more?
yeah, so definitely go to datacoral.com to kind of see what we're up to. And you can also sign up to our kind of weekly newsletter where we kind of write up about our own stuff. We have a blog that you can kind of go to as well. Yeah, and write to us at hello@datacoral.co if you want to learn more about the product and try it out too.
Awesome. Cool. Well, Raghu, this has been a lot of fun. Like I always love these types of conversations. So would love to speak with you again in the future, and definitely keep me in mind if you want to talk more about your metadata first architecture. This seems very, very intriguing. So
Thank you
cool.
so much.
Awesome.